convert sine to cos or cos to what? To sine. Any of those two. Right, so here today I like to change sine to cos. So I'm going to say sine 2 theta is equal to cos theta minus 50 degrees. So we convert that to cos, so that will be cos 90 degrees minus 2 theta. Okay, this will be equal to cosine of theta minus 50 degrees. Okay? Now, once you have got the same trig ratio on either side of the equation, obviously your reference angle is going to be this angle here. But this is cos now. Okay? So we write here 90 degrees minus 2 theta is equal to plus or minus. Then we put the theta minus 50 degrees inside brackets. Then we add k times 360. Okay, where k is an integer there. Okay? So your reference angle is theta minus 50 degrees. Okay? As I've said in the past, I'm going to repeat it because I saw it in the test when I was marking. There is no need to write reference angle equal to some number. There is no need. I'm sure you can memorize that this is the reference angle. The value you get from the calculator, that's your reference angle. Is that difficult to memorize? Huh? Yeah. You see, your textbook writes a reference angle a lot, but it doesn't mean you have to follow what's in the textbook. That's not what it means. Okay? A textbook is a guide. Okay? You don't have to take it. That's why have you ever seen me doing an example in the textbook? Yes. No. I think you probably don't understand the difference between a questionnaire, an exercise, and an example. An example was done by the author. The author provided the what? A solution. That's an example. The author did the question and gave you the what? The solution. Okay. If a question is like this not all these 6 questions, they are not examples. They are exercises for you to what? To do. Because the working out and the solution is not provided. Okay? Alright. So from here, we can break this out because this binomial here, or rather this reference angle, is a binomial. Because it's a binomial, it complicates things to just work with plus or minus as is. So you break up the plus or minus into the positive and the what? And the negative. So if I start with the positive, I'll end up getting theta minus 50 degrees plus k times 360, where k is an integer. Right? And then obviously here you take the theta to the left, so you get minus 3 theta. That will be minus 140 degrees plus k times 360, where k is an integer. And then you divide both sides by negative 3. Please, when you are dividing, because this is something which I saw when I was marking that there are some of you haven't understood the concept of dividing here. Okay, you haven't understood the concept. When you are dividing, what do you divide by the coefficient on the left-hand side? You divide the term itself on the left-hand side by its coefficient. You divide the angle here, okay, by the coefficient. You also divide the k times 360. Now, that k times 360, please be aware that it's positive k times 360. Because k can be negative or what? Positive. So if you divide with a negative coefficient like this here, this sign here, it will change from positive to negative. And this k times 360 here, when you divide, just divide the number in degrees by the coefficient. The k remains there. Don't touch the k. The k can be positive or negative. Don't touch the k. Divide the 360 or the 180 by whatever coefficient. Okay? Don't do what Mr. Chibonda didn't do. Okay? Yes, if you didn't see me doing it, don't do it. Do what you saw me doing. So this will be theta will be equal to, we divide here, what answer do you get? 20 what? 30 something. 40 something. Okay, 40. Positive. It's 46, 67. Two decimal places. Then this sign becomes the minus. 36 divided by minus 3 obviously that will give us 120. So this will be k times 120 degrees, where k is an integer. Okay? Then you stop. This is a general solution. Sometimes the question can say solve. If the question says solve, but you are not given any restriction for the angle, you just get your general solution. If the question is explicit, then you just find the general solution. You don't have to complicate things. Okay, right? Yeah, don't complicate things. The general solution is very, very easy, but you can complicate it yourself. Okay? And I've tried to make it as easy as possible. Now that I've dealt with the positive of this angle, now I have to deal with the negative now. So the negative of that angle, we will have 90 degrees minus 2 theta is equal to minus theta minus 50 degrees plus k times 360, where k is an integer. Okay, as we speak, we have got some grade 12s who still don't understand the general solution. Yes, maybe some of you can teach them. Okay, so this will be 9 degrees minus 2 theta is equal to minus theta plus 50 degrees plus k times 360, where k is an integer. Okay, so this will give you minus theta is equal to minus 40 degrees plus k times 360 degrees, where k is an integer. Okay? Then the coefficient of the theta is -1. So we have to divide the left hand side and the right hand side by -1. So when you do the division, you divide that by -1, divide that by -1. Here you divide the 360 degrees by -1. Okay? Or we can say divide the k, there is fine. So you end up getting theta being equal to positive 40 degrees minus k times 360 degrees, where k is an integer. Okay? So this will be the second general solution. The first one is this one here. This is the first one. So there are only two because we are dealing with cos here. Right? If you find the general solution for sine as well, you should get two of them. Now you are spoiled for choice because you can convert the sine to cos like how I did, or you can convert the cos to sine. Both solutions will be acceptable. Okay? Are you following? Yeah, please. I'm going to... Can you stop that? I'm sure for the past week or so you were laughing. Right? I'm sure for the past week or so you were laughing. You want to carry on laughing. Please. Okay, just to emphasize here. So, here we converted sine to what? To cos. When you get here, for this question, if you take the positive of our reference angle there, you won't get a solution. Okay? But if you take the negative, you will get a what? A solution. So I end up having 2 theta equal to that. Then you divide both sides by 2, so you get theta equal to minus 7.5 degrees minus k times 180 degrees, where k is an integer. Okay? What? Okay. Right? So that's your only solution there. If we convert the cos to sine, okay, it's also possible that we might get one solution. But let's check it. Okay? Let's check it. So if we do the reverse, so that will be cos theta minus 45 is equal to sine 30 minus theta. So this will become sine 90 degrees minus theta minus 45 is equal to sine 30 minus theta. This is so easy. Okay? So easy. So you get sine 135 minus theta is equal to sine 30 minus theta. Okay? Now, you all know that sine has got 2 general solutions. So here, our reference angle is this angle here. So, we end up having 135 minus theta. I'll start in the first quadrant, so I'll take the theta minus, so to take the 30 degrees minus theta first, then I'll add k times 360 there, where k is an integer, right? Then if you take the minus theta to the left, you end up getting 135 degrees minus 0 is equal to 30 degrees plus, okay, can you stop that? Okay, now this doesn't make sense, okay, which means there is no what? No solution. That's what it, as long as the theta disappears in the equation, it means you have no what? Solution. And you don't have to worry yourself there. If you did everything right, you will be on track. Okay? Then the second one now, we'll say we say 135 degrees minus theta is equal to 180 degrees minus that reference angle there. Now this one is going to give us a solution. Okay? So here if I simplify, I'll get 150. Take the 150 to the left, I'm going to get minus. Okay, sorry, I won't take it to the left, but I'll do it the other way around. Take the 135 to the other side. Then take the positive theta to the left, I'll get minus 2 theta. It's going to be equal to 15 degrees plus k times 360. Okay? We're following that. Then because of the coefficient there, if I divide both sides by -2, okay, in this case I don't have space, but I'm going to do it mentally. And I'm going to assume that you are all following. So we divide both sides by 2. By -2, we get theta equal to minus 7.5 degrees minus k times 180 degrees. Now this is normal in terms of sine and cos. You can get this angle part, the first angle being the same in terms of sine. But when it comes to the k times 180 or k times 360, there can be a difference in the sine. But if you substitute the values of k and you test the solutions, you get the same solutions. Are you following? 1 week should not cause you to be very rusty. Okay? 1 week should not cause you to be very rusty.